We are tearing apart mass, weight, density, pressure, and resultant force practical data today to secure you top marks in your Cambridge IGCSE Physics 0625 exams. No fluff, no basic recaps. We are diving straight into exactly what separates a failed paper from a top band score.
Look directly at this two-student duel on density data analysis. On the left, we've got a seriously flawed answer from student A. On the right, student B provides a top band, examiner-approved answer. Now, both students technically arrive at the number 2, right? But their execution? Worlds apart.
Pause and predict right now which student wins the marks. Do it, because this exact scenario creates massive timing pressure and absolute confidence shocks in the actual exam hall. If you chose student B, you are absolutely right. But understanding exactly why student A failed is the actual secret to hacking this mark scheme.
So, student A lost because of these painful, incredibly common mistakes that examiners just see constantly. And what's really interesting here is how simple these errors are to fix. Missing units, rounding your numbers way too early in a multi-step calculation, giving super vague explanations like, oh, the reading might be wrong, instead of mathematically identifying an anomaly, and just using the wrong variables entirely.
And this brilliantly illustrates how easily you can score literally 0 marks on a practical evaluation, simply because you didn't fulfill the command words with correct physics terminology. You can do the math perfectly in your head, but the examiner cannot give you credit for what is trapped inside your brain. They can only grade what is explicitly on the paper.
Let's look at Section 1, the ordinary revision trap.
See, ordinary revision just focuses on memorizing facts, but as this direct examiner feedback shows, you actually lose marks by not linking your evidence to your scientific reasoning. Read that quote again. Conclusions are not supported by the data. That means you stated a fact, which might even be true, but you completely failed to prove it using the actual numbers provided in the table or graph. Now, in a moment, I'll show you the exact examiner clue that completely flips your answer from a borderline C grade to a guaranteed A star. But first, you absolutely need the framework that makes that specific clue obvious to you when you're sweating under exam pressure.
Which brings us to Section 2, the top band answer framework. Listen closely, because the crucial point here is to follow this 4-step sequence for every single practical calculation or explanation question you ever face. Step 1, explicitly state the concept or equation. Step 2, cite the specific evidence or data from the provided source. Step 3, apply your scientific reasoning. And Step 4, wrap it up with examiner-safe wording. Do not leave a single mark to chance.
Let's actually see this in action. If you're asked to evaluate resultant force, you don't just guess or write a loose, chatty description. No, you state this precise definition right here. You write out the formula, you substitute your specific numbers from the question, literally showing your workings, and you append the correct unit. That is exactly how you lock in all the available method marks.
Moving into Section 3, Spot the Hidden Errors Interactive Challenge. Let's test this out.
Look really closely at this practical investigation table for calculating density. At first glance, it looks like a completely standard, fine set of results, right? But if you apply the mindset of a Cambridge examiner, you should start seeing massive red flags everywhere. Try to identify the specific errors in the table's design and its data accuracy.
I want you to pause this explainer right now. Seriously, grab a piece of paper and write down exactly what is wrong with this table before I show you the examiner's red pen correction. Did you spot the missing units in the column headers? Did you catch that glaring data anomaly? Let's find out.
Section 4. Think like an examiner. Let's see how you did.
Notice how the top band answer explicitly points out the missing units in the header. The volume and density columns completely lack their standard units at the top. It also doesn't just lazily say row 3 is weird. It correctly identifies trial 3 as an anomaly, stating its exact value of 2.4 grams per cubic centimeter, and applies the actual scientific reasoning that it must be excluded from the average to ensure reliability.
And boom, here is that key examiner clue I promised you earlier. Marks are rewarded for the method, not just the final number. Always, always explicitly show your substituted values with units. And if a question asks about the practical setup, you must critically evaluate the apparatus and safety precautions. That right there is the gold dust that separates top-tier candidates from everyone else.
This brilliantly illustrates the exact checklist you need to rapidly run through in your head to secure method marks for any practical data question. Fix the table design by checking headers. Verify your graph scale and gradients.
Address any physical uncertainties in the apparatus. Always mention repeating readings to improve reliability and clearly state relevant safety precautions.
Let's lock this in with Section 5, the final exam blueprint.
Right before you move on to the next question in the exam hall, you must do a final answer check using these 4 critical steps. 1. Check your significant figures. 2. Verify your units actually match the required answer line. 3. Assess uncertainty. And 4. Do a reality check. Confirm if the resultant force or pressure value is actually physically reasonable for the context of the question. Like, don't lose silly marks because your calculation accidentally implies a toy car has the mass of Jupiter, right?
So, congratulations, you have successfully hacked this entire section of the forces syllabus. By utilizing this framework, hunting for anomalies, and thinking exactly like an examiner, you have entirely bypassed the painful learner mistakes that completely destroy grade boundaries.
However, mastering forces creates a massive, totally unresolved problem for you. You are still completely vulnerable to the fatal examiner traps, waiting in the thermal physics and waves sections of the 0625 syllabus. Getting forces right is great, but it won't save you if you're just bleeding marks everywhere else on the paper.
Leaving your preparation here means risking literally everything you've just learned today, which is exactly why watching our Physics 0625 Last 7 Days Revision Map Explainer is your absolute mandatory next step to survive the final exam. You need to map out the rest of these syllabus traps, and you need to do it right now.
Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations.
So, are you ready to map out your final 7 days, conquer the rest of this brutal syllabus, and absolutely guarantee that top grade? Ask yourself, what hidden trap is waiting to blindside you in thermal physics? Click the explainer on the screen right now and let's find out.